Good morning. This is Kavipriya, Assistant Professor, EC Department. I am going to discuss about the topic rectifier. And this is my flow of presentation. I am going to discuss about the basics of rectifier and then about the construction working principle and applications and drawbacks and advantages of half wave, full wave and bridge rectifier. We can start with the basics of rectifier. So what is a rectifier? So rectifier is a device which converts a AC signal into a DC signal. So what are all the components that is present inside the rectifier? The foremost component is a diode. So diode have a unique property. It allows the flows of current in a forward bias condition and it blocks the flow of current in the reverse bias condition. So because of this unique property, a diode acts as a rectifier. We can start with the half-wave rectifier. So half-wave rectifier is a very simple form of rectifier and it has been employed in the simple circuits. So the half-wave rectifier has three important components. They are nothing but a diode and the transformer, and the resistive load is being used. This is the circuit diagram for the half-wave rectifier, which has a diode and will be having a transformer, and the load is being connected at the secondary part. And next is a working of a half-wave rectifier. Will be applying a AC signal to the primary part of a transformer and will be getting a secondary voltage which is being applied to the diode of the half-wave rectifier. So diode is one which will be conducting only during the forward bias condition and it will be blocking the flow of current in the reverse bias condition. Here during the positive half cycle of the input signal, diode will be conducting and the AC signal will be rectified into a DC signal. And during a negative half of the input signal, diode will not be conducting, hence we won't be getting a rectified DC signal for a AC signal during the second half or negative half of the AC input signal. So we'll be getting only one half of a signal is being rectified and other half of a signal is not being rectified, which means that only the positive half of a signal is being rectified and negative is not being rectified in the half-wave rectifier. And main important thing is that the output whatever we are getting at the rectifier, the output of the half-wave rectifier is nothing but it is a pulsating DC. It is not a pure DC signal. It has some ripple content in it. To remove the ripple content, a capacitor filter or even an inductor filter can be used. So the capacitor and inductor can be act as a filter in removing the AC content from the DC content, which is nothing but removing the ripples from the DC waveform. And next is the advantages, drawbacks and applications of the half-wave rectifier. The main important advantage is that the power loss in case of the half-wave rectifier is very less and also the efficiency is higher and we have a very low ripple. The drawback is that the power loss is very low, power loss is very high when compared to the full wave rectifier, and also the output voltage is also very low and it contains the ripples which is very high when compared to the full wave rectifier. So it is a very simple and basic form of rectifier. So it is being employed in the low power simple battery charger circuits and it is used in the soldering iron circuits and it is used in the firing circuits and it even used in the AM modulation circuits as a detector. And next is a full wave rectifier. The main important drawback of the half wave rectifier is that only a positive half of a signal is being rectified, whereas in case of a full wave rectifier, the entire complete AC waveform will be rectified into the DC. And this is the circuit diagram for the full wave rectifier. Will be having a important component here is a center tap transformer. So we'll be having two diodes instead of one in case of the half wave rectifier. So we'll be having a two diodes and we'll be using a center tap transformer. So during the positive half cycle of the AC input signal, diode D1 will be conducting and the positive half will be get rectified, and during a negative half cycle diode D2 will be conducting, and the diode D2 will, because of this D2, the negative half cycle will be rectified. So the entire AC input signal will be converted to a DC signal in case of the full wave rectifier. So during a positive half diode D1 will be conducting, and during a negative half of the input cycle D2 will be conducting. The advantage is that efficiency is higher when compared to the half-wave rectifier, and also the ripple factor is being get reduced, and the output voltage is higher when compared to the half-wave rectifier. Drawback is that because of the center tap transformer, the cost is high, the space occupied by this half-wave full-wave rectifier is somewhat higher, and it is not suitable for small voltage rectification. Application, it is being used in the battery charging, it is used in the motor control, and it is used in the power supply. Third type of rectifier is a bridge rectifier. The main drawback of this full wave rectifier is that it uses a center tap transformer which occupies the most spaces. So to overcome that, in case of bridge rectifier, we won't be using a center tap transformer. Instead, we'll be using a 4 diodes here. In case of a half-wave rectifier, we'll be using a single diode. In full-wave rectifier, we'll be using a 2 diodes along with the center tap transformer. And to reduce the complexity of the full-wave rectifier, bridge rectifier is being used, which has a 4 diodes over here, and the center tap transformer is being eliminated here. We'll be having a 4 diodes, and we'll be applying a AC input across the any 2 arms of the bridge rectifier, and we'll be getting an output across the remaining 2 arms of the bridge rectifier. So during the positive half cycle of the AC input signal, the diode D1 will becomes the A becomes positive and the B becomes negative. Because of that, diode D1 and D3 will be conducting, and the AC input signal positive half will be getting rectified into a DC, and during the negative half of the input cycle, A becomes negative and B becomes positive. Hence, diode D2 and D4 will become forward bias, and D1 and D3 will become reverse bias. So D2 and D4 will be conducting, and the negative half cycle is being rectified to DC. So this is a waveform for the bridge rectifier. Input is a AC. In case of bridge rectifier, as like full wave rectifier, the complete AC cycle will be converted to a DC. The main advantage is that the center tap transformer is being avoided. So the space complexity and the circuit complexity is being avoided. Advantage is that efficiency is higher than the half-wave rectifier. The output of whatever output we are getting over here is same as that of the full wave rectifier. But the main important advantage is that compared to the full wave rectifier is that the center tap transformer is being avoided. Here both the positive and the negative is being rectified. Drawback is that the circuit of the bridge rectifier is somewhat complex. When we use more diodes over here, the more power loss will be occurring, and the voltage drop over here because of the 4 diodes is somewhat higher. Application is that it is used in all mobile phones, it is used in the laptops, televisions, and it is used in the audio systems. And this is an assessment question. Which of the following is not a type of rectifier? It is a precision half wave, bridge rectifier, peak rectifier. All are the types of a rectifier. Bridge rectifier is an alternate for the full wave rectifier. A simple rectifier which has a ripples in the output waveform, which makes it unsuitable as a DC source. To overcome this, we can use a capacitor in parallel to the load resistance. So capacitor is one which removes the ripple content from the DC and make it as a pure DC. So that's all about the rectifier, and we have discussed about the half wave, full wave and bridge rectifier, construction, working as well as the applications. Thank you.